Okay, ladies and gentlemen, welcome back to video lessons. It's been a while, huh? Today's lesson is about factoring polynomials using the GCF. So the first thing we're going to talk about is what the GCF is. That's the greatest common factor. Greatest common factor. And this is something you learned back in 4th or 5th grade. Should come back to you relatively quickly, but let's take a look at it. Factors are things that multiply together to give you that number. So the first thing that we want to do is make a list of all factors of those two numbers. So factors of 12, 1 times 12, 2 times 6, 3 times 4. Now you'll notice the way that I wrote that out. I always start with 1 and I think about what factor I need to multiply it by to give me 12. And then I notice when I get to the middle there are no more numbers and I know I've gotten every single factor. I'll show you again. So factors of 8 are 1 and 8, 2 and 4, and 3 doesn't work, so it's those 4 factors. So I'm looking for the greatest common. So the biggest number that they have in common is 4. So the GCF of 12 and 8 is 4. Why don't you try the GCF of 7 and 20 right now on your own? One times 7, and that's it. 1 times 20, 2 times 10, 3 doesn't work, 4 times 5. Is there a GCF? There is no GCF bigger than 1. The greatest common factor is 1. All right, so let's move on and apply that to algebra, to variables. So if I have x cubed and x to the 7th, I need to list out the factors of each of those. The things that I multiply together to give me x cubed are x, x, and x. The things that I multiply together to give me x to the 7th are x, 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 x. So the factor that they have in common is 3 x's. So the GCF is x cubed. That's the greatest factor that they have in common. Let's try the next one. The next one has both variables and numbers. So we have two things that we have to do. 6 has factors of 1 and 6, 2 and 3. 4 has factors of 1 and 4 and 2 times 2. So the greatest common factor of those numbers is 2. Then we've got to look at the variables. We've got x to the 5th and x to the 3rd. X, 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 and x, x, x. They have x cubed in common. What you'll start to notice is the smallest exponent is the greatest common factor. So our GCF here includes both pieces, 2 and x cubed. Why don't you try this one? A little trickier. We've got 3. Okay, a squared b to the 5th and a to the 4th b to the 7th. Remember what I said on the last slide. The smallest exponent is the GCF. So that means the GCF of these 3 terms is a squared b squared. All right. So let's move on to the second half then of our goal today, factoring. Remember the goal was to use the GCF to factor. Factoring simply means to distribute. It's doing the distributive property backwards. It's the opposite of distributing. So the first step, anytime we're asked to factor, will be to find the GCF of its terms. Then we will write the polynomial as a product by factoring out the GCF. That means we're going to divide by the GCF. The remaining factors in each term will form a polynomial. So for example, 5x squared plus 15x has a GCF of 5x. So if I divide each part by 5x, I end up with x and 3. We'll look at more examples here in a minute. You don't need to write all those down. So let's try our first example, factoring out the GCF in letter A. First, let's find the GCF. We've got 6, 9, and 12. That's 1, 2, 3, and 6. That's 1, 3, and 9. And it's 1, 2, 3, 4, 6, and 12. So our GCF of the numbers is 3. Okay, so I'm going to erase all that, get it out of my way. GCF is 3. Now looking at the variables, the smallest exponent, x. So my GCF is 3x. So I'm going to divide each piece by 3x. I'm factoring out the GCF. So the GCF is going to go on the outside of a set of parentheses. I'm undistributing. 6 divided by 3 is 2. X cubed divided by x to the first is x squared. Negative 9 divided by 3 is negative 3. X squared divided by x is x. 12 divided by 3 is 4. X divided by x disappears. So, my final answer is 3x times the quantity 2x squared minus 3x plus 4. The GCF always is on the outside of a parentheses, and what you divide out goes inside the parentheses. Let's get rid of that mess. All right, so why don't you guys try letter B on your own, and then we'll give it a try together. Okay, so the GCF of the numbers, 14, 7, and 7 is 7. Let's look at the x's. I've got an x, and the y's. I've got a y. All right, so that goes on the outside of the parentheses. And I'm going to divide each thing by 7xy. So 14 divided by 7 is 2. X squared and no y. 7 divided by 7 is 1. X squared divided by x is x and no y. Negative 7 divided by 7 is negative 1. X divided by x, y divided by y. I've only got a 1 left over. Now, if I wanted to check my work, anybody have an idea for how I would do that? Well, you would do the distributive property. You would multiply it out and check to make sure that it equaled the same thing. 7 times 2 is 14. X times x squared is x cubed. Y plus 7x squared y minus 7xy. So you can see that checking is very easy to do as well. Alright, so you've got homework, more practice on My Math Lab, Chapter 6-1.